Guys, welcome to day 12. It's hard to believe, but it has been 1 month since I've seen you guys. Our last day of school was March 13th. It is now April 13th. Hopefully, one more day, one more month from today, I'll be seeing you guys from face to face. All right, today's topic. Significant figures. And what significant figures is it's a method for reporting your answer. So how do I know when to round, or how do I know how to round? Well, significant figures is basically a set of rules that determine how many digits you can keep in your final answer. Now, a lot of times in chemistry, we will just give you word problems, and a lot of times those word problems are going to dictate how many significant figures you can keep. But I want you guys to realize that in the real world, significant figures are determined by the tools that you use. So, your tool, it may go to the 10th of a gram, it may go to 100th of a gram, it may go to 1,000th of a gram. Ultimately, it is the tools that you use, the instruments that you use to measure things that determine the amount of sig figs that you can use. Now, there's a couple of different ways we can look at sig figs. We can look at sig figs just by identifying them by looking at numbers, but then tomorrow we're going to focus more on how do you know how many sig figs do you keep when you actually do mathematical computations. So before you need to do mathematical computations, you need to understand how to recognize significant figures. So let's start with easy ones. All non-zero digits are significant. Keep in mind, this has to do with measurements. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Digits 1 through 9 will always be significant when using a measurement device, a tool, a scale. Okay. Now zeros are where it gets a little bit tricky. All right, let's first talk about when they are significant. Okay, final zeros after the decimal are significant. What does that mean? I call it the twice right rule. So let's say we have a number like 1.000. These are final zeros after the decimal, and because of that, they are significant. So if you want to look at a number like 1.000, it has 4 digits. It has 4 significant figures. Let's go up here and do an example for 1 through 9. So the number 419, it has 3 digits, and therefore it has 3 significant figures, okay? All right, let's do another one for the twice right rule. Let's see, get a number like 50.0, okay? 50.0, final decimals final zeros after the decimal are significant. So the 5 is significant and the final 0 is significant. I would say that this has 3 significant figures. But what I didn't tell you is, why is that middle 0 significant? Well, that is our next rule. That is called, what I say is the sandwich rule. Any 0 that is in between significant figures is also significant. So let me give you a few examples of the sandwich rule. All right, the first example would be, let's say 1,001. So 1 is significant, and because these zeros are sandwiched in between, those zeros are also significant. So if you look at a number like 1,001, it would have 4 significant figures. But let's look at another example. Let's say we're looking at, I'm just going to make a number up here. Let's say it's, switch back to a bright color. Let's say we have 70,000, okay? 0.0. All right, so the 7 is significant. Final zeros after the decimal are significant. All these other zeros in the middle get sandwiched in between. So 70,000 decimal 0 would have 6 significant figures. 1, 2, 3, 4, 5, 6. 6 digits, all of which are significant. So zeros, if they're final zeros after the decimal, or if they're sandwiched in between, they are significant. Now let's talk about when they're not significant. And guys, zeros can be quite tricky, and we're going to go through some examples here in a few minutes. So I think if we do some examples, it'll come clear. But let's talk about when they're not significant. Simply when they are placeholders. And what is a placeholder? I thought all these zeros in the examples above were placeholders. Well, placeholder has a very specific definition. So placeholder zeros are not significant. So rule placeholder 1, zeros right of a non-zero digit but left of an understood decimal are not significant, okay? So what does that mean? Let's look at the number 70, okay? 70 does not have an actual decimal, so that would be an understood decimal. So it is left of a non-zero, but right of an understood decimal. So 70 would have only one significant zero, or one significant figure. The 7 is significant, but the 0 is just a placeholder. But how do I show 70 with two sig figs? I can do that a couple of different ways. I can do 70 decimal. And if I write 70 decimal, now that 0 does become significant. Or there's one other strategy. You can put a line over a 0. Now, a line does not mean a repeating decimal. In the case of significant figures, a line means that that is a significant 0. So if I wrote 70 like that, it would be two significant figures. So the first example has an understood decimal. We don't actually draw an understood decimal, one sig fig. The second one has an actual decimal, so it does have two sig figs. And the third one has a line, so it also has a two sig figs. Okay, let me give you some more examples. Okay, leftmost zeros in front of non-zero digits are also not significant. So what does that mean? Let's say we're dealing with a really small number, like 0.00123. So these are leftmost zeros. These are simply placeholders. So the 1, 2, and 3, all non-zero digits, are significant. So that number, 0.00123, would have three significant figures. All right, so the way I'm going to do this is just kind of dig in. All right, so 365, all non-zero digits are significant. So that would have 5. Oh, guys, I did forget to tell you one rule. When counting or using clearly defined values, you can have an unlimited number of sig figs. I'll explain that when we get to some of the examples. All right. Second example, 409. Well, all non-zeros are significant, and that 0 in the middle is what I say sandwiched. Okay, so that 0 in the middle is significant. So in the case of 409, we have three significant figures. All right, next example. All non-zero digits are significant. Now, leftmost zeros in front of non-zero digits are just placeholders. So 0.021 would have 2. All right, what about 5.0? Well, we know that all non-zeros are, and this 0 is what I call the twice right rule. Final zeros after the decimal are significant, so that 0 would be significant too. All right, 970. We've got a 9 and a 7, which are significant. Now, this kind of falls under the category of placeholder. It's left of a significant figure, it's to the right of a significant figure, but left of an understood decimal. So 970 would only have two sig figs. All right, what about the next one? We know the 4, the 2, and the 3 are. This 0 is sandwiched. The final 0 is twice right, but the first three zeros are placeholders. So this would have 5 significant figures. Now, I didn't tell you about scientific notation, but it's actually quite easy. Just ignore the exponent, okay? So all non-zero digits are significant. Final zeros after the decimal are significant. So this number, written in scientific notation, has 4 significant figures. Let's do another one, okay? So we know that all non-zero digits are significant. We've got a couple in there that are sandwiched, but also final zeros after the decimal are significant. So for this particular example, I got to count real quick. It looks like we have 9 significant figures. All of them are significant. All right, 7 days in a week. 7 is only one digit. But we know from experience that there are exactly 7 days in a week. So for this example, it would be unlimited. There is exactly 7 days in a week, not approximately. So because of this is a clearly defined value, it has unlimited sig figs. All right, what about 30 days in November? Well, we know that all non-zeros are. If we just said 30 days, 30, then it would be 1. But because November does have 30 days, we can also say unlimited. All right, guys, I know that sig figs can be a little bit tricky. I do encourage you to read the part in your book having to do with sig figs. I am going to give you some examples to do, and tomorrow we're going to focus more on rounding and measurement. So if you guys want to do some of these are for practice, and we'll talk about rounding. So don't worry about number 3, don't worry about number 4. So numbers 1 and number 2, kind of what you're doing. Don't forget to complete the Google form because that's how you're going to get graded. But if you guys have any questions, shoot me an email, leave a comment on the classroom, and I'll get back to you. All right, guys, it's been a month. Hopefully in another month, I see you, I miss you, I love you. I'll talk to you soon.